Hello, my name is Jason Yang. My instructor or professor is called Faisal Kaleem. This video is for my individual project for the course ICS 382.50, or also known as CYBR 332, or in short, computer security. As a disclaimer, this video is for educational purpose only, and I'm not liable for any damages that could be caused using demonstration. As technology is advancing year by year, it seems that we are nearing the digital age, where everyone is constantly using their devices for many uses such as entertainment, education, communication, news, weather, economy, laws, and almost anything that has to do with our daily life. In the digital world, full of numbers and data, it's another world different than our physical world. The digital world, also known as cyberspace, is perhaps one of the most dangerous places due to no security or laws to enforce upon the criminals, also known as hackers. Of course, I could be talking about the dark web, but even some other domains are possible to be dangerous to those who do not know much about cybersecurity, leading to costly damage. There could be malicious attacks that could lead to stolen confidential information, such as ransomware that forces the victim to pay money to get access to their data. In this video, I will be talking about what are malicious attacks, its history, how they affect others, what are malware, the history of public malware, how they created, and ways to prevent or lower the risk of malicious attack and malware. Next, I'll be using a virtual machine to show how malware infects computers, and later show some files that act like viruses, which eliminate some functions of a computer. In the end, I'll be summarizing about malicious attack and malware. So this is a disclaimer that I'm not a computer virus creator or a hacker. I'm also using code that are created from the sources of the internet to demonstrate what a virus or a creatable file can do to a computer. I would not be responsible for any damages to your computer when you try to follow my demonstrations. And always use a virtual machine to test viruses or other malware, but be sure to know how to use a virtual machine first. I am not trying to persuade you to become a computer virus creator or hacker. Creating malware will lead you to jail. Pretty self-explanatory. If you're creating something out of nothing, it can be fun. But if you're creating something that results in destroying lives or property, it is fun, especially to the victims. Creating a computer virus can cause a lot of damage to internet users, corporations, government, and even yourself. There's some computer viruses and other malware that are not harmful to people physically, but they are very harmful to their devices and computers. You'll be considered a criminal if you release your virus and it infects many other virus devices. You will not be hired by security firm or antivirus companies by creating a malware. When your virus has done a lot of damage, you will not be famous, but you will be a famous criminal instead. So malicious attack. What is it? It's similar to a malware, but malicious attack are where hacker they try to configure or try to perform other attacks, especially in cyber warfare or cyberspace, to the victim, such as company, um, local corporation, local company, local corporations, government. So, what is malware? Malware is a software that is designed for malicious attacks or activity. Comes in all kinds of types and each operates differently. In the past, it affects mostly computers, but now it also affects other devices including smartphones. So why do malware creators create malware? There are 5 reasons. it makes them money, a large sum of money. It prevents the victim from performing attacks on their devices. When the malware creator have a person that they just wanna um, not they don't like, they can prevent that victim from using their devices. The third reason is bragging rights. There's some that want to have the most damages, and so they can say that they're the best malware creator. The fourth reason is so they can launch denial of service (DOS) and DDoS attack. So DOS is when they flood the network or the servers with so the computer DOS is only one computer, one system will not be able to process efficiently. DDoS is attack for multiple computers in a designated area. And also, they will also create malware for mining cryptocurrencies. Um, so here is a computer virus. It's not really, doesn't look like this. It looks more like a file. It's similar to a biological virus, but a computer virus infects the electronic, while biological virus infects biological species or life form. What is a virus? It is a file or executable file that begins to infect the computer after it is executed. Like a virus, it infects the host and transmits to another host to infect them as well. Unlike a virus, computer virus harms electronically, not physically. It can alter the way a computer functions. It attaches itself to a program or document. It can also corrupt or destroy data. How a virus infects computer. The virus file is downloaded into the computer. The user runs the virus program. The malicious code executes and the virus is spread to other files in the infected computer. Some results of the infected computers/system are the computer's performance slower than usual, new program that you do not remember downloading appears, programs behaving strangely, or the computer overheats and shut down. There are many types of viruses. Here I have 9 different types of viruses. First are boot sector virus. It can take control when you start your computer. Web scripting virus is coded into browsers and web pages. It can infect when you are on the web page. Browser hijacker. It directs you to another different website. Resident virus. It goes into the system's memory. Executed when an operating system starts. Direct action virus. It comes into action when it is executed. Polymorphic virus. It changes its code every time it is executed. File infected virus. It inserts malicious code into files that perform certain functions or operations. Multi-party virus. It can infect many ways, including program files and system sectors. Macrovirus. It uses some macro language for software applications. Infected through open document or email attachment. There are many popular viruses, but I have 4 that are very dangerous. First, the I love you virus was an attachment to an email that was sent to random individuals. After clicking on the attachment file named loveletterforyou.txt.vbf, the file will overwrite system files and personal files. This led to a damage of $15 billion. Kled send email and trick others into eliminating other viruses. It infects files and spread through the network. This led to a cost of $19.8 billion. Zeus is an online theft tool that infected the web in 2017. It has infected 88% of Fortune 500 companies, 2,500 organizations, and 76,000 computers. The damaging cost is about $3 billion. Stuxnet was created not to harm the public, but used as a countermeasure to nuke systems in Iran. It was created from government engineers in the US. It has helped wipe out certain systems and cost Iran a lot of money. The cost is unknown. For this virus, it has been used for a good cause instead of a bad cause, which means that there are a few viruses that are beneficial to certain society. Next is worm, or also known as computer worm. So what is a worm? It's like a virus, but it operates on its own without the victim running it. It spreads independently. It arrives through a software vulnerability. It can steal data or create backdoors so the hacker system can control the victim's system. It modifies or deletes files in the system. So if you're comparing a worm with a virus, a worm automatically operates when it is in the system. A virus has to be run in order to process. How worms infect computers. Hackers discover the vulnerability. They write code to exploit it. When the worm is in the system, they look for other devices within the network. Once they discover other devices that have the same vulnerability, they infect the devices. They can then continue to spread exponentially. So there are many types of worm. Here are listed 5. First, email worm. Our email boxes are the main use. The mail can have link or attachment when downloaded the worm. The worm deletes or modifies data and destroys the network. Internet. Spread through internet or local area network connection. It checks for vulnerability and infects if the vulnerability is present. File sharing network worm. Additional files that are downloaded to look like regular file or extension. It can locate folders and destroy other files. Instant message and chat room worm. Not as harmful as other worms. It sends messages contain the link to website or attachment or downloadable file, which then can infect the system. IRC worm. Internet relay chat application worm that function like the instant message worm that also destroys the system. Here are some popular worms. So big worm that costs about $30 billion of damage to the internet. It has multiple versions such as SoBig.A to SoBig.F, with SoBig.F being the most damaging. It has harmed Air Canada and other businesses. MyDoom, which was responsible for 25% of all email. It used other addresses from infected machines to those addresses. It created a web of computers called botnet to perform DDoS attacks. It created $38 billion of damage to the internet. Code Red was well known to deliver a DDoS attack to the US White House website, which caused the White House to change its IP address. It had also infected nearly 1 million hosts. It ran through the machine's memory. 2.4 billion was the cost of the damage. Slammer randomly select IP address and infect onto other machines. It was well known for hitting banks in US and Canada. It caused about 1.2 billion of them. Sasser was created by a 17-year-old German computer science student called Sven Jaschke. It has crashed millions of PCs. This virus caused about $500 million of damage. Trojan horse. This is a picture of a Trojan horse, but Trojan horse is a file or a program. What is the Trojan horse virus? Similar to the Trojan horse in Greek mythology, where the wooden Trojan horse was a gift to Troy in order for the Greek army to invade and take over Troy successfully. It's a program that masquerades like a normal program. Contrast to virus and worm, Trojan horse do not replicate or spread throughout the system. Once infected, the creator of the Trojan horse can remotely control the system. Trojan horse can steal useful information such as passwords, which can be used for hackers to blackmail victims of the infected system. Types of Trojan horse. Backdoor Trojan. It allows the creator of Trojan to have full access to the infected computer, including sending, receiving, launching, and deleting, displaying information, and rebooting computer. It can also join with other infected computers to create a botnet or zombie network to perform malicious activity. Exploit Trojan. It codes is code that target a vulnerability in an application software. Trojan Banker is still information such as an account for online banking, credit or debit card, or online transaction system. Trojan DDoS. It uses the infected system and other infected computer to perform a DOS attack to web addresses. Trojan Downloader. It can download and install new versions of malware. Trojan Dropper. It prevents antivirus to scan the malicious program. Here it is continue. Trojan Fake AV report fake threats to the user's computer for money. Trojan Game Thief steal user account information from online gaming. Trojan IM is still login, user, and password to instant messaging phone. Trojan SMS send text messages from the infected device to premium rate phone number. Trojan Spy can see the data input from keyboard, take screenshot or get a list of running applications. Trojan Mail Finder record email addresses from the infected computer. There's a history of the popular Trojan horse. There's 3. Spicer was one of the first Trojan horse that had infected about 1 million PC. It had made pop-up appear frequently that tells the victim to download a software application. Arachnid Trojan appeared since 2013. It delivered ransomware allow hackers to use an infected device for mining cryptocurrency. Zeus/Zbot record keystroke when users are logging into a bank account to be able to get username and password. Ransomware. What is ransomware? A malware that locks users' file until ransom is paid. The creator can threaten to sell or leak the data to the public. He/she decrypt the data when they receive the ransom. There's no guarantee if the victim will be able to get their files back. It can impact from individual to large corporation, thus exceeding a demanding of $1 million. Popular ransom. CryptoLocker was one well-known ransomware that locked at least 500,000 users from accessing the personal file. Evgeny Bokachev, the leader of the gang of hackers for CryptoLocker, made about $30 million in 100 days. In June 2014, he and his group were taken down. WannaCry, created in 2017, that went through 150 countries, business, hospital, and government. It was stopped by a 22-year-old security researcher. It cost about $4 billion a day. Adware. What is adware? A software that is programmed to force ads to pop up during the use of the infected computer. It reads and records keystroke and personal information as well. Website the user clicks on. It can be downloaded from drive-by download, which means the malware instantly downloads once the user is on the website where the malware is present. Unlike virus, adware cannot spread to other computer/devices. Some adware can perform man-in-the-middle attack, which is where the creator of the malware can configure message between conversation or web spoofing, where the hacker adjusts the web browser to get the victim's personal information. Popular adware. Fireball, a browser hijacker created by Rafflecheck, a Chinese digital marketing agency that infected more than 250 million computers, takes control of the browser and changes the home page to a fake search engine. It prevents the victim from configuring the browser setting. A purge. Also, another browser hijacker that forces a lot of ads to make it difficult to browse the internet. It also prevents the user from opting out or subscribing to it. Dollar revenue installs a browser toolbar that tracks internet searches. It also shows a pop-up window. Gator, an adware that changes ad on website to their ad. It also reports the browsing history and credit card number that's a common adware that shows ad and pop-up ad. It also can take full control of the browser and can override the computer's registry to launch during startup. Spyware. What is spyware? It is malicious software that spies on the victim and collects information such as personal information, banking information, or other valuable information. It is difficult to uninstall once it has been installed into the infected computer. It can be installed by security, vulnerability, phishing, spoofing, misleading, marketing, software bundle, or mobile device spyware. Types of spyware. There is password stealer, malware that record only password from infected computer. The information can be stored in the infected computer or downloaded into the creator's computer. Info stealer, malware that record all kind of information like username, email addresses, and even other media files. Keylogger, malware that record keystroke, website visited, search history, email discussions, chat room dialogue, system credential, and even capture images, audio, and video from connected device. It also gives the hacker information on documents that were printed. History of spyware. In October 1995, the word spyware was used in the forum in Usenet. 1999, Elf Bowling, a freeware game, was found to contain spyware. The first anti-spyware called Opt-out was developed the following year. Rootkit. What is rootkit? Malware that is difficult to detect in computers and other devices may give the rootkit creator the chance to take control of the computer. Access to personal information such as credit card information or banking information. It is disable security software or report input from keyboard. The types of rootkit include hardware or firmware rootkit, rootkit that comes from destination that is installed, infect storage or the system BIOS and even the router. The creator can intercept the data. Bootloader rootkit, rootkit that accesses the bootloader and replaces it. Bootloader loads the computer's operating system. Memory rootkit, rootkit that is stored in the computer's RAM. Application rootkit, rootkit that replaces the standard files such as Word, Paint, etc. and can be recognized by the victim. Kernel mode rootkit, rootkit will focus on the operating system of the computer. The cybercriminal can configure the operating system functions. History of rootkit. The idea of modifying the computer system was acknowledged in 1980. In 1999, NT-rootkit, a rootkit that configured Windows NT, appeared. Later in 2009, the first rootkit for Mac OS X appeared along with the Stuxnet in 2012. Sony created and released their own rootkit secretly in 2005 to protect copyrighted publications. They faced backlash and worsened reputation. Blue Pill, a hypervisor level, was introduced in 2006. Snowball, a hidden malicious malware, was present in 2008. In 2015, Lenovo was found to release the rootkit in order to download dedicated software. So, in the end, why do we study malware? If we know more about how malware works, we can take action to lower the risk of getting it. We will know some safety precautions to perform when we encounter malware. We can mitigate the spread of viruses and malware or even malicious attacks. We know what type of malware that infected our system and know what step to perform for that type of malware. And there's a new method called malware analysis. It is a method to understand function, purposes, origin, and impacts for malware. Malware research to analyze the code of the malware to find alternative ways to prevent malware and malicious attacks. It's also to study the impact of malware and its use cases. Computer security incident management. If malware enters the system, the response team can perform malware analysis on malicious files. Malware research to study the newest method used in the creation of malware. Indicator of compromised extraction. Anti-malware software use malware analysis to carefully study and prevent the latest malware. Types of malware analysis. There are two types. First is a static malware analysis. Malware is analyzed by running the code. Signature base, which is binary, is determined by calculating cryptographic hash. It can be reverse engineered through a dissembler. It uses virus scanning, fingerprinting, memory dumping, ineffective against new or unknown malware. And there's dynamic malware analysis. It is where the malware runs and the system is analyzed. Behavior based, which observes the system functionality. It can be reverse engineered using dissembler and debugger. It involves certain functions like registry changes, API calls, and memory writes. More effective in a higher detection rate than static malware analysis. Here are the stages of malware analysis. The higher the level, the more difficult and complex the method are to implement. From easiest method to implement to hardest. Fully automatic analysis, static properties analysis, interactive behavior analysis, and manual code reversing. Stage 1. Fully automatic analysis. It involves using a detective tool that analyzes discovered malware. Some tools like Cuckoo Sandbox can run codes and give report. There are some alternatives that are paid or free. Stage 2. Static probabilities analysis. This is the phase where the malware analyst decides to do more analysis or stop the analysis. Include using a virtual machine that's disconnected from the internet and tools such as pstudio. Pstudio uses file hashing to search after other malware repositories to see if the file has been analyzed before. It compares any difference in the code seen in regular file. Stage 3 Interactive Behavior Analysis. The malware is executed and the analyst observes the result. Some malware will not execute if it detects that it's in an environment where it's analyzed. Some actions that malware can perform include adding or updating new or old files, installing new services and processes, modifying the registry or changing the setting, connect to suspicious host IP, create mutex object to infect new hosts. Some tools used are Wireshark looking at network packet, Process Hacker looking at processes, Process Monitor looking at the real-time live file system, registry, process activity. ProcDoc Pro provide analytical data of the activities observed. Stage 4 is manual code reversing, the final stage where the debugger and dissembler are used to look at the code of malware closely. The malware can be examined for its uses and function. There can be detail or discovery between the client-server on the command and control side. It can take a long time to reverse the code of the malware. Here are some ways to prevent malware. Always have the latest version of your operating system and application software. Subscribe to antivirus software to detect malicious files. Scan computer and smartphone using the antivirus regularly to block and delete any suspicious file. Backup files regularly. Scan files from USB or other sources before running them. Use virtual machine as a safety precaution for any downloading of suspected malware. Don't open emails from unknown sender. Mouse over link before clicking on them to make sure it's a safe web page. Stay up to date with current malware and learn what each one does. Antivirus. It is software that protects against most, but not all, malware present on the internet or well-known. You can have additional functions / features such as password manager, where you contain multiple passwords from multiple accounts. Real-time scan is scan file that will download it in real time. Automatic update, it updates the database of the antivirus. Protection for multiple programs, it protects programs that are commonly used. Protecting browser, another optional browser that runs like a browser but protects secure information. Cloud-based behavior analysis, it detects zero-day malware instantly. Effective, efficient whitelisting and mark certain file as trustable and give them default access, and more depending on the antivirus. Here are some popular antivirus. This Bitdefender, Kaspersky, Webroot, Trend Micro, Norton, ESET, AVG Technology, F-Secure, and Sophos. Next is gonna be a demonstration of using VirtualBot to detect code that changes the computer behavior or state. Before creating a file that can alter the way your computer regularly runs, make sure to use a VirtualBot because once your is to reduce to minimal the harm of your operating system. So this virtual box is used as a secondary operating system, as if you bought a new computer and you can do whatever you want. And once you aren't, if your computer is infected, in your guest operating system is infected, then you can delete it and create a new guest, and it will work as usual, and it won't affect the host system. So here is one code for the creating a executable file. Is used from Notepad. X equals message box parenthesis error 0 plus 16 error here. This error is the subtopic. This error here will be the main or the heading. So if I were to save this, save as, and then I can put it all file and save as like chrome.bbs and save it. Is that? So we have to click it, and then it'll create an error here, error message, and then every time you click on it, you will hear the error message. So if we copy this and paste it 3 times, there will be 3 windows popping. So let's go save, close it, click on it. There will be 1, 2, 3 error. So this kind of functions in a way that make you think it's kind of like a pop-up. You can go 3 times. So look here, there's 3 of these. So if we change this number, it ranges from 0 to 5. I'll put 1. And then 16, it ranges from 16, multiple 16, all the way to 64. So I'll put 32 here. And changing these numbers, but they have the range, will alter the way the appearance of the error window. So I'm gonna save it, and then here it's gonna create this error, which is different from the one as previous. But on the second line, it's gonna create the same error, and then it's also gonna create the same error again. So here is another cool notepad file. It's very self-explanatory. Echo off, color 2, and when it is percent random, it will generate random number. So let's save this as matrix dot file. Okay, and then we'll run this. Let's see what it do. So here I call it matrix because it randomly goes in a loop infinite while that's running. Generate random numbers, and it looks like a matrix. Pretty cool. And when you close it, it'll just turn off on process. So here is the next file, the last one. It's not gonna be harmful to your computer, but it'll just it doesn't turn on after you restart. So after you restart, everything will be normal. So here is the code. This is the message it will print. So basically, it will just print this word infinite times until you turn off the computer, and it will print onto like text files and stuff. So let me create a new text document, and then I'm gonna run it. Seems like nothing's happening. Go to new text document here, and it will type for infinite number of time. The only way to fix this is just to restart your computer. I'll restart my computer, and then it'll be it'll not happen. So infinite time. So the only way is to shut down the computer. Shut down. So here is after I restarted. I did not save the new text document because it was very it went through a lot of iteration of typing, so I did not save it. And then still work. The rebooting. So here is the, so everything worked. This typing virus, well, it's not technically a virus, but these files are just made for fun. The typing virus is made for it's active until you shut down the virtual machine, your virtual machine, or your computer. So here is the current trend for malware. And malware now targets mobile devices, instant messaging, massive multiplayer online role-playing game player. There is less malware control for mobile devices, but social engineering is used more. Instant messaging has become popular targeting systems such as AIM, MSN, etc. MMORPG players' accounts are hacked by the cybercriminal to access rare and valuable digital items to sell for profit. Social engineering is more common now and may seem to occur more in the future. Here's the future of malware. As technology is advancing, newer malware are created to infect many computers. Antivirus are slowly catching up to eliminate malware. Malware are slowly developed to create malicious attacks that last longer than before. There are malware that implement a method called hatchback, which is coded to intercept the researcher's machine if it detects that it's being studied. Some also perform DDoS attacks on researchers if they are close to the command and control system. There is some malware that blacklists investigators who are trying to access the botnet server. Here's the works cited. And throughout the video, I have mentioned that malware is a destructive artificial and digital item that no one wants to have. There may be someone who you know that may have malware and do not know if they have malware. It is quick to assume that malware can come in all kinds of shape and form. Some are very dangerous while some can cause minimal damage. In the future, there may be more malware that no one could even think of. As technology is advancing, so are malware as well. We must protect our data and our devices from other hacker and malware creators. We also should know the basic malware to know how to keep ourselves and others safe from the internet. Thank you for watching.